In a different video, I talked about WEP and the problem with WEP. The problem was that this initialization vector, a number that repeated periodically, by the way, was sent plain text along with the shared key to the receiver. And the shared key was encrypted, but the initialization vector was not. Now let's take a look at WPA and see what was added. This TKIP thing, or Temporal Key Integrity Protocol, was added in 2003. By this time, we were cracking WEP in just minutes, and it was obvious we needed to do something very, very quickly to fix the problem, and WPA was a temporary fix. By the way, it was a temporary fix because AES was not yet, which is a stronger algorithm than RC4, was not yet available on machines. If you remember back to the Windows XP days, you might remember that SP, I believe it was Service Pack 3. When Service Pack 3 came out, it was a really big deal, and you had to have Service Pack 3. Well, that was the patch that allowed WPA2, but WPA2 was not just the market wasn't ready for it yet, and so this was a temporary patch to change the TKIP, in other words the initialization vector part of WEP, in order to make this stronger. So let's take a look at the difference here. In this case, the sender now has, here's the initialization vector, and this changes with every frame, and then here is the password, Sklunge. So Sklunge is, by the way, with WEP we couldn't choose what we wanted here, but with WPA we can. So this is no longer a shared key, but a pre-shared key, or PSK. I should have put that in here and I didn't. Now we encrypt both the initialization vector and the key. So remember that with WEP we did not encrypt the initialization vector, and it was shorter as well. But now we are going to encrypt it and send it encrypted, concatenate it with this key here, concatenate it, and send it. You might notice something else interesting here. Here this one starts with this ampersand, but this one starts with a 1 when I send it. What's that about? Well, we also added a sequence number, and that sequence number, this is not the exact way that it was built, by the way. This is just for a logical demonstration purpose. But the sequence number was used so that somebody couldn't just replay what was going on and authenticate their way into this wireless router. So the sequence numbers were also added to prevent that, because if the same sequence numbers reoccurred, then the router would say, nope, that's not the right one. We also added something else called the hash of the message. So this is a fingerprint. A hash is a digital representation of a message that cannot be decrypted back to the message. It's a one-way encryption, if you will. So all of these things together made this much stronger. The hash of the message was sent so that at the receiver we would know that nobody messed around with our message, because if we also made a hash of the message, we better get the same number as the one that was sent over to us. If we don't get the same number, then the message has been changed. With the sequence number here to avoid replay attacks, and then the encryption of the initialization vector, so that we can't have the we can't tell when we have a repeating number. This is constantly changing. And then the lengthening of this initialization vector. All that together made WPA much, much stronger than WEP was, and got us by for that year or so until we were finally able to get WPA2. One other thing I want to mention here is this. The pre-shared key, and I call it a pre-shared key rather than a shared key because as a pre-shared key you determine what it is. As a shared key, the wireless router determines what it is. The other thing we added was a personal and enterprise version. Now, enterprise is using a protocol called 802.1x, which means we're going to have a separate server to do our authentication for us. So this wireless router no longer does that. It offloads the authentication process to a server, and then once the server gives the okay, then the wireless router will let you on. You can't do this at home unless you have an authentication server, because if you tell your wireless router, yeah, I want to use WPA Enterprise, it's going to laugh at you. Now what it's going to do is ask you for an IP address for the authentication server, and you're not going to have one. So you won't be able to use that. You have to use the personal one at home. But the nice thing about 802.1x is that it allows everybody to have a different password in order to get onto the network. So we use those in enterprise industrial situations where we want everybody to have their own unique password to get onto our Wi-Fi service.